In the previous chapter, you have learned how to describe the wave that's right on top of my head. You have learned how to use terms like amplitude, frequency, period, wavelength, wave speed, longitudinal waves, and transverse wave. We talked about also very key hallmark wave phenomena. Okay, so in this chapter, we're going to look deeper into what happens to this wave. You notice this wave is really alone. It's just chilling here, moving left, moving right, like shuffling left and right. Now, what happens when this wave meets another wave? This will be the focus of this entire topic. We are going to answer the question, what happens when two waves meet together? It is a love story. Are they going to fight? Are they going to fall in love? We don't know. But there are principles, like all things in physics and sciences, that will tell us and help us predict and guide our thinking to how to perceive two waves when they meet. Okay, so maybe I'll just pause the wave here. I'm just going to adjust a bit. Okay, so let's say these two waves meet like this. Okay, because just now I pressed the play button, so you know they move around. But let's say I pause, I freeze the wave, and they meet like this. What is the result of the wave? What will happen when the blue wave, that has an amplitude of 0.5, meets the red wave? Okay, you cannot see, I zoom in a bit. Hey, nowadays if you're watching this on YouTube, you can zoom in, just pinch on your device. Okay, but anyway, this one is 0.5. Okay, 2.5 boxes. This one is 1. So let's use our intuition or instinct. What happens when 0.5 meets 1? Tick tock, tick tock. 0.5 meets 1. Feels like it will become 0.5 plus 1, giving us 1.5. Let's see. This purple one is the result of these two waves. So the purple wave is the addition. What happens when the red wave meets the blue wave? So 0.5 plus 1 is 1.5. In fact, you can check out the negative portion. Here, the blue wave will have an amplitude of negative 0.5 plus an amplitude of negative 1. So negative 0.5 plus negative 1, we will get, ta-da, negative 1.5 here. Okay? So this adding of wave has a very fancy name behind it. Very fancy name. They call it superposition. We position the graph and we superposition them. Okay, so this is the principle of superposition, and we're going to write that down. So here we are at our notes. As you can see, I screenshot a tiny drawing of the simulation that we saw just now. And let's say I were to label the blue wave. Okay, this one is the blue one. I'm just going to label the blue wave Y1. Okay. And then I will label the red wave Y2. And the purple wave will be the resultant. And resultant here would be equal to Y2 plus Y1. Okay, so which means if I want to find the resultant, let's say at this point, this resultant at this peak here would be, so let's check out Y2. Y2, so anyway, maybe I'll just draw an arrow here because I need some space. So the Y2 plus Y1 here will be equal to, so Y2 is this peak, I'll zoom in a bit. Okay, Y2 is this peak 1.0 plus Y1, which is 0.5. That is how we arrive at our 1.5. Okay, and I would repeat the same thing again, but I guess just to make sure the video is not too long, and I think you get the idea already. If I repeat the process for this one, at this point here, the resultant wave will be equal to negative 1.0 Y1 plus negative 0.5. So finally, I will get negative 1.5. This point. Okay. So what we did here is we sum up the waves. Okay. So we should also write down how this looks like, in a general statement, because these are important process of sciences. We see something, we understand the main idea, the theory of it. Now we want to write down what happens in a general sentence. So the condition here, if you remember, is what happens when two waves meet. Okay, so I'll write that down first. So when two waves meet at a point, the resultant wave is the sum of the individual waves, y2 plus y1. So this resultant wave, right, actually what are we adding when I say y2 plus y1? We are adding the displacement. Okay, so like for example, if I were to take every point along this orange dotted line, the displacement of y1 or the amplitude of y1 is 0.5 and the amplitude of y2 is 1.0. So these two are displacements. So it will be more accurate for me to mention that the resultant wave displacement is equal to the sum of its individual, because you take y1 plus y2, there's two wave meeting with individual displacements. Okay, so this is the formal statement. Make sure that your definition for principle of superposition carries 2 points. Number one, you have two waves meeting, have to meet, no meet then no magic, must meet then only got magic. So when two waves meet at a point, the resultant wave, the result of them meeting is the sum of the individual displacements. And if you want to, you can say individual displacements of each wave. I'll write that down for you. Essentially, we are saying in fancy sentences that the resultant wave is equal to the first wave y1 plus the second wave y2. Okay. So just to give you another example before I move on to something else, I have here a second picture. Okay. So right now you realize that the blue wave and the red wave a bit not the same like the previous one. Okay. But don't forget, which one is your y1? Y1 is the blue color. Y2 is the red color. So you can see y2, the displacement is 1. Let's say I go and take this point also lah. All right, I take this point, this orange dotted line. Okay, I'm going to zoom in a bit. So this y2, the displacement is 1. However, the displacement for y1 is negative 0.5. So if you take 1.0 plus negative 0.5, you will get the resultant. This one is the resultant here. So this one is y1 plus y2, which is actually positive 0.5. 1.0, I write the whole thing lah. 1.0 plus negative 0.5. It is a sum, so generally speaking, I don't really care whether which one you add to which one, as long as you add them up. Right? That's the principle of superposition. And whenever you are lost, whenever we level up some more and we decide to change things, okay, when we decide to change all of these numbers, we move the wave, you don't scared. At the end of the day, what we're looking at is something exciting that look like this one. Okay, so the interesting thing about this, oh, so big, okay, is that based on how these two waves meet, okay, so just to help you contextualize, I got principle of superposition. I'm going to take y1 plus y2. So y1 is red color. Okay, and y2 is green color. So red plus green, we get blue. Cool? Principle of superposition. But life not always like this, ma. You don't always meet your best friend at the best time so that when you meet, wow, the energy level maximum. Don't have sometimes you meet slightly out of phase like that. Aiyo. And sometimes you will meet like this. So you see, depending on how they meet, which is also really dependent on the angle, the phase relationship. Remember the previous chapter? We get different blue color wave. Remember, the blue is the resultant. So we'll have different blue color wave. So whenever you are lost, go back to basics. What's the basic? I will always have to take this red and add to this blue. Add to this green, which will give us the resultant. We are adding up waves. Plus, like kindergarten. You got this, all right? So that's it for the principle of superposition. Whenever you're lost in this chapter, because after this, it's just going to go a bit chaotic. We're going to make the waves meet in a different way, all right? That'll be the next video. But whenever you're lost, go back to the very basic principle of superposition. Says that the resultant wave is the sum of the individual wave if red wave meets green wave. All right, I'll see you in the next video. Try some examples. Bye-bye.